Okay, now it's 3.4, yeah, 3.4. So homeostasis in the human. So if you have read up, it's good. Okay. So if you haven't, please do it soon. Okay. We are going to the end of the chapter 3. I do it quite slow. Okay, for you to pick up. Okay. I hope you all can give me some feedback. Okay. So 3.4, homeostasis in the human. Okay, so what is homeostasis? Okay, what is homeostasis? Okay, if you remember with Form 4 we have learned also. Okay, so homeostasis means to maintain a relatively constant. So this is the keyword. Okay, the relative constant, and then it is the internal environment that is important here. Okay, internal environment means the one inside your body. Okay, we have seen this and we have explained this. So internal environment means inside. So homeostasis, actually there are two. Okay, one is a regulation, is a maintenance, right? So it may be is a maintenance to have a constant. Okay, but sometime okay, it has this positive feedback. Okay, but what we want to see here is negative feedback. So negative feedback means wherever there is a changes, we bring it back to a normal situation, or normal, or the standard internal environment that is suitable for the body to function. So example of internal environment that we can see here are the glucose level. Okay, we have learned that when glucose level up and down. Okay, concentration of carbon dioxide. Okay, this one is related to the pH, yeah, the pH of the blood. And then blood pressure. Okay, this one also we have learned blood pressure during we learn the transport. Okay, then last one is osmotic pressure. So osmotic pressure, we will see it here. Okay, we will see it here in this 3.4. We will focus on more here. So osmotic means water, yeah. Okay, osmotic pressure is more on water. So when we talk about to remove water, the first system that we can think of will be the excretory system. So these are the excretory system, and I believe this part you have known. Okay, this part. Okay, what are the excretory organs? Okay, inside the excretory system. Okay, so we will not talk about this. Okay, what we want to know is what is meant by osmotic pressure. So osmotic pressure, it is the pressure related, or pressure measuring the amount of salt and the water, okay, inside the blood. So if you have too much salt in the water, means your osmotic pressure is higher. So just keep this lah. The opposite is the balik one, another way around. Okay, so if you have low sodium, means you have low water potential. So maybe you will see why I only show sodium or salt here. Okay, what happened to the water? So when the sodium is high, automatically we will understand the water is lower. Okay, it's always go opposite, salt and water. So you have more salt in the blood, means you have lower water concentration in the blood. Okay, and then this is regulated by the kidney. So if we go some revision, yeah, we have some revision. This is what you have learned in Form 3 actually. Okay, so we have left, right kidney. Okay, then you have this blood. Okay, so you will see actually we have two big blood vessels. Okay, one carry the blood in, another one will carry the blood away from the kidney. Okay, and then it will, when it carry away, it will enter the vena cava, so to the heart. Okay, this one is from the aorta, okay, to the kidney. Okay, so this is just nice that you will follow your what I have learned in your chapter 1 from 5 transport. Okay, so where we start. Okay, yeah, this renal artery means from aorta it go into, when it enter kidney, the word renal means kidney, so we use the word renal artery for the blood vessel that enter kidney. Okay, so please, yeah, this one is both left and right enter, and then both left and right went out. Okay, so after that from kidney, it will be, the water will be collected inside the urinary bladder. Okay, later we will see what is happening inside the kidney. Okay, so this is our kidney. So the real kidney very contain a lot of bloods, huh? Okay, very bloody. Okay, not good. Okay, now bloody. Okay, pardon me. Alright, now, so you will see this one. This one is a cross section. Okay, a drawing, a diagram showing how your bloods, or how our blood going. So you see renal artery here. So flow in, and then renal vein out. Okay, there's one more tube here. Okay, a ureter. This one will collect all the urine after filtration process. So basically, the kidneys can be divided into three parts: the cortex, the outside one, okay, medulla inside, and then pelvic, okay, nearer to the vein. Okay, that is the first thing that you should know. Okay, so in a drawing, okay, this is what we can see: cortex, okay, medulla, then you have pelvic. See, so pelvic is the one that contain a lot of this collecting duct. Okay, this is collecting duct. Yeah, later we zoom in here, you will see actually this part is one nephron. Yeah, this front. So nephron is actually you have this distal, Henle, everything, and then the Henle is inside the pelvic. The loop of Henle is in the pelvic. The rest will be in the cortex. Okay, it's just arrange millions of them arranged along the way. Okay, arranged along the way. So from the loop of Henle, then they will have this collecting duct entering the ureter. So all the collecting duct will end up in the ureter, carry to the bladder. Okay, so the pyramid of the medulla is, this is medulla, right? So the pyramid means the one that is pointing. Okay, pointing is actually contain a lot of collecting duct. Okay, collecting duct. CT, I will use the word CT. Okay, so renal artery, blood in, renal vein, blood out. Okay, so we will see what is nephron. Yeah, this is the nephron. So what we can say here, okay, see this is one nephron. You imagine this unit is repeating, okay, millions of them repeating in here. You see this box? Okay, so millions of them are inside the kidney, okay, to do the filtration process. Okay, so this part, the loop of Henle, this one the name is loop of Henle, LH. Okay, LH will, you see it here, yellow part, yeah, it will go inside the pyramid. Okay, so then you have this tubule, and that tubule later we'll see what is the meaning. And then the blood, okay, this is the tube, this is the renal tube. Tube means it contains water or the filter. Okay, filter the water lah. But the blood, okay, the blood only here. Okay, you see, only inside the glomerulus, or sorry, only inside the Bowman capsule. Okay, see, this is the blood. Okay, it doesn't go inside the tube. It go around, surrounding the tube. Okay, that means you can imagine if this is the tube, there are a lot of blood vessels around here. Okay, the one that go in and then out, this out one will go round, 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 and then out. Okay, later we see how lah. Okay, next. Okay, this is what we meant. Yeah, you see. So from the grey one, okay, this is arterial. Arterial means enter. So enter this Bowman capsule. Okay, Bowman capsule. I hope you have read up the parts, the name of the nephron. Okay, the Bowman capsule. So at the Bowman capsule, we have a lot. It's just like a bowl. Okay, mangkok. Okay, so a bowl. So that bowl contain of a lot of blood vessel, blood capillary. So this capillary will push everything in the blood in high pressure inside the tubule. The grey color is the tube. Okay, inside the tube. So this grey color is the tube. Yep. Okay, so it's a grey color tube. There are another grey, but this Bowman capsule, you see, joined here to the tube, and then until the yellow one. Okay, so also the tube. But if you see properly, they are smaller. Yeah, this one, the capillary network, can see. So the capillary network is actually branching in and out throughout the tubes. Okay, this is how the after Bowman capsule, the filter, it filter out everything that is not needed. Okay, not needed in the tubule. Okay, it will return to the blood capillary. Okay, this is how we done. Okay, so we will see. Yes, this is a simplified diagram to show what I want to say just now. Okay, so you have the blood capillary. See, black, the red is the blood. Okay, so from the blood, okay, now before it go out, it will go and round and surrounding all the tubes. So the waste and the nutrient or the substances will diffuse into the blood if it's needed by the body. Okay, if not needed, it will remain in the tube. Remember, yeah, the one in the tube is the one that being removed. Okay, it will be removed. If I do not want, then it will be remain inside the renal tube, or the blue one. Okay, if it remain inside the tube, it will remove as urine. If it go back to the blood vessel, it means return to the body, whatever that you need. Okay, so there are three process here involved when you form the urine. First thing is ultrafiltration. Ultrafiltration happen at the Bowman capsule only. And then reabsorption will be happening at the PCT, okay, proximal convoluted tubule, LH, loop of Henle, DCT, distal convoluted tubule, and CD is collecting duct. Okay, so this fourth place is where the reabsorption happen. Then secretion is three here, except of LH. Now secretion and reabsorption, we will see what's different here. Okay, so here is more on the hormone secretion. Okay, next we will see, yes, the nephron at then the nephron itself. Okay, so you will see the green one now. Okay, the green is actually the tube. Now the blood capillary is surrounding the tube. You see, the blood capillary is in red surrounding the tube, and then when it come in, it from the artery, and then after it surround the tube, it go out through the renal vein. Okay, renal vein. Okay, so first thing we will see how it is. Yeah, here this one. Okay, this dotted line, the line in blue. Okay, the line in blue is showing the section in the kidney. Okay, the cortex section and the medulla. As I said, this part is actually inside the medulla. Okay, the loop and the loop of Henle, and also collecting duct. Okay, collecting duct and loop of Henle. These two sides is in the medulla. The rest of it is in the cortex. Okay, so it will be darker in color. Okay, it contain more bloods. Okay, now how it's formed? Yeah, the first process, ultrafiltration. So we zoom here. Yeah, from here we zoom to this one. Okay, yes. So when the blood from the renal artery enters, okay, of course the high pressure will make everything go out. You see the black color arrow? Okay, so you have glucose, amino acid, urea, water, and minerals. So all this will remove or filter inside. Okay, we call inside the bowl. Okay, inside the Bowman capsule. So we call it glomerular filtrate. Okay, the word glomerular filtrate down here. Okay, glomerular filtrate are all the substances that is being diffused or filtered into the Bowman capsule. Okay, it's from the blood, except the red blood cell actually. Okay, too big. And then some of the drugs that are bigger then cannot be removed from the blood. Okay, unless except for all those. Okay, those are smaller because of the high pressure. It will be all entering the Bowman capsule. Okay, then this one to narrow down, this one to the renal vein. Later it will go around the tube. Okay, so why we have this filtration? Ultrafiltration means, ultra means very high pressure. So you see the reason here. So because of the bigger diameter of the afferent arteriole, then the renal vein will have narrow and smaller diameter. So this difference in diameter will cause it to have a very big pressure. Okay, and this big pressure will press, or we will remove everything into the Bowman capsule. Okay, and then the blood of capillaries that is inside the Bowman capsule are called the glomerulus. It's a network of capillaries, yeah, inside the Bowman capsule. So this is the wall, and then after that it will enter the cavity. Okay, the cavity or the renal tube. Okay, yeah, we see here. Yes. Okay, this one is another zoom in. Okay, the kidney, I zoom in one little dot here. This is one nephron, and from the nephron, we zoom into this Bowman capsule. And the Bowman capsule, it will look like this.